In this lesson, we are going to solve systems of equations by graphing. You will see in the first problem that I have two equations listed here. What we're going to be doing for the next 3 videos actually is finding different ways to find the intersection point for these two equations. You'll notice they're both linear equations. The top equation is in slope-intercept form and the bottom equation is in standard form. So to start, I'm going to graph my first equation that's listed there. You'll see I have a b of 1. So I'm going to start at 1, and then I have a slope of 2. So I would go up to right 1, or down to left 1. And then I go ahead and connect my dots for that line. Bear with my crooked line, I'm not going to use a straight edge here. So there is my first line graphed right there. My second line, since it's in standard form, I can graph using intercepts. Since most of you like to graph from slope-intercept form, I'll go ahead and solve this and do it that way. But if you like to graph by intercepts, by all means, go ahead and do that. To get y by itself here, I'd subtract x from both sides. So I have 2y equals negative x plus 12. So I have 2y equals negative x plus 12. I'm going to then divide all 3 spots by 2. So I have y equals negative 1/2 x plus 6. So there's my equation in slope-intercept form. My b value is 6, so I put my first point at 6, and then since my slope is negative 1/2, I would go down 1 right 2. Go ahead and connect those dots. And then what we're looking for is where these two lines intersect. So we're looking for this point right here. That's actually going to be our answer. So I would say my ordered pair is 2, 5. And what that tells you is that's where we have an x and a y value that would satisfy both of these equations. So if you substituted in a 2 for x and a 5 for y, both of these equations would make true statements, something like 5 equals 5. And that's what we're looking for. This is the only problem we're going to do like this. I will say that the graphing method works great if you have a graph available. The problem will be when we end up with graphs that intersect at not integers, so at fractions or decimals. If my intersection point for the graph happened right here, I'd have to estimate where that was happening, and that's not what we want. We want an exact answer. So in the next few videos, you're going to learn about the substitution and elimination method, and those work for non-integers also, so those work for all numbers.